All right, good morning, class. Okay, today we'll continue our lesson, a short lesson. Okay, this is about vectors. Okay, previously I assigned some work for you. If there's any questions, any problems, please get in touch with me through WhatsApp or Telegram. All right, so today we move on to the next part. Determining resultant vectors of two non-parallel vectors. Okay, you can refer to your textbook. This is on page 90. All right, now when you have two non-parallel vectors, example, let's say I've got an A like this and a B like this. Okay, as you know, resultant vectors will be the summation of two or more vectors. All right, so when you have non-parallel vectors like this, okay, to combine them to get your resultant, okay, there are actually three laws that you can actually use. One is known as the triangle law, second is a parallelogram law, the third one is a polygon law. Now, which law we apply depends on the number of vectors. So example, okay, now let's say I've got two parallel vectors A and B, something like this. This is vector A and this is vector B. Okay, vector A starts here, vector B ends here. So this is my initial and this is my terminal. So my resultant vector is actually a line that connects my initial to my terminal point. Okay, now why it is known as a triangle law is because when we actually combine vector A, vector B and the resultant vector, you actually form a triangle. Okay, right. The second one is a parallelogram law. A parallelogram law, same thing. Let's say we use back the first example, A and B. Okay, so this would be my resultant vector. Just like up here, it's actually the same thing. But what I can actually do is, now another option will be I move my B to this side. So you see B is drawn parallelly here and A can actually be moved down here. So long as they are parallel and they are actually the same magnitude. So what happens is the whole entire diagram here forms a parallelogram. So normally what happens is a parallelogram law can be used to solve vector questions where it actually involves angles as well as magnitude. Right? Okay, now the third one will be polygon law. Polygon law is used when you have more than two vectors. So example, you got vector A, vector B, vector C and vector D. So your resultant will be from where the vector starts and vector D ends here. So your resultant is this. Okay, so these are three laws that you can actually use, depends on what is given to you in the question. All right. Okay, so we move on to the next one. Okay, you can refer to it. Skill practice 8. Okay, this is on page 92. Okay, the question says they want you to find this is 9. It's on page 92. Okay, the question says for each of the following, draw the resultant vector P plus Q either using a triangle law or a parallelogram law. So what we can actually do is, okay, if you notice these are two non-parallel vectors. So depends on what you want to use. Okay, so what I'll do is I'll draw my vector P. This is my vector P. Just make sure the vectors are parallel to the original vector and the magnitude must also be the same. So vector P ends here. So this is my terminal point. So from this point onwards, I will actually draw my vector Q. Okay, sort of parallel and the magnitude will be the same. So this is my Q. So vector Q ends here. So now from the initial to the terminal, this is my resultant vector of P plus Q. Alright, so it forms a triangle law. Okay, likewise for this, I've got P and I've got Q. All right. Okay, so what I'll do is I draw my P first. That's my P. Okay, P ends here, meaning I can actually start my Q. Okay, initial to my terminal. So that's my vector of P plus Q. Okay, so this would be my resultant vector. All right. Okay, so now let's say we have a question like this. This is on skill practice 10. Skill practice 10. This is on page 93. Yeah? Okay, question 1. This is question 1. The question says, a diagram shows a pentagon PQRST. Alright, they want you to find the resultant vector for each of the following vectors. Sorry. Okay, so this is a polygon. Now this is a pentagon. So we start off with RS. Okay, RS means the vector actually is moving from point R to point S. So it's this way. ST, S to T, this way, and T to P, this way. So the vector starts here and it ends here. So that means my resultant will be vector RP. Right? Okay, yeah? So based on this is a pentagon given to us in the question. All right, another question similar to this. Okay, let's say I've got vector TS. TS is here. RQ. RQ is here. SR, SR, and QP. If you notice, these vectors are not written in order. So what I will do is I will actually rearrange it. So we'll start with TS. Okay, TS. Okay, plus after TS, I will actually move to SR. This is my SR. I put my SR first. We want a flow of the vectors, huh? Okay, so I've taken this, I've taken this. Okay, plus once it stops at R, I will use this RQ this way. Okay, and lastly QP this way. So that means my vector starts here, initial, and this is my terminal point. So that means my resultant vector is actually moving from T to P. So that's my resultant vector. All right. Okay. All right. One more example. Okay, this is question 2, same practice, skill practice 10. All right, the question says find the resultant vector for these 3 vectors given. Okay, so there is no sequence in how we want to do it. So maybe I will start with this. So this is my first vector. Ends here. So you can either pick this or this, up to you. So maybe I'll go for this. So this is my second vector drawn. Ends here. And this would be my third vector. So it starts here and it ends here. So this will be my resultant vector. So if you notice, this is actually a 3 vectors. So this would be my resultant. So this is not a triangular law. Alright. Okay, so this is more of like a quadrilateral. This is not a parallelogram, this is a quadrilateral. Okay, so what you can do now is, for today, please read up from page 90. There are a few concepts there in the textbook. Okay, I want you to complete SP9. This is on page 92. Okay, SP9. and SP 10. Okay, for your work today. Thank you, class.